The key concept reminds us about what a cross-section is and how we can use that cross-section to solve problems. Remember, a cross-section is a two-dimensional shape. This is what we see when we cut a three-dimensional figure. The shape and dimensions of a cross-section of a rectangular prism, so that's this one over here, are the same as the faces that are parallel to the slice. So when we slice it horizontally, like so, then it takes on the same shape and dimensions as the top or the bottom of that same rectangular prism. For a pyramid, a cross-section will depend on how it's sliced. In the picture here, we see that you get another triangular figure here that is equal in height to the height of the pyramid and also equal in length to the side that it is parallel to, in this case, the left side. Okay? And remember, the height of the pyramid is the height from its top vertex to its base. Now let's work on questions 4 and 5. Number 4 says the divider in a desk drawer is a cross-section that is parallel to the front, there's the front, and the back of the drawer. What is its shape and what are its dimensions? So here's your divider. Right there. And let's take a look at its shape. First of all, look at the dimensions. So going across the top of that divider would be like going across the top of the drawer. And the dimensions of the top and bottom of the drawer are rectangular, and it's 8 centimeters. Then we see that there is a height to this divider, which also happens to be the height of the drawer. In this case, 5 centimeters. So this shape for the cross section is a rectangle that is 5 by 8 centimeters in length and width. Now about number 5. We're going to use this diagram to answer the questions, and you see the pyramid here. Okay? So it says, draw the cross section that is formed when the pyramid is sliced vertically. Vertically means top to bottom. Okay, through its vertex and its right face. So it's going to be one that, here's the right face right here, and it's going to come down there, and it's going to come across there. That's where I'm slicing it, straight through that middle point and the right side. So what we have here is we have a triangle in shape, and it has dimensions along the bottom of the triangle that are the same as the bottom front edge of the pyramid, which is 9 millimeters. And then we need to look at the height of that pyramid. Okay, and that height is a perpendicular height from the top to the bottom. The height of the cross section is the same as the height of the pyramid, which is 10 millimeters. And then part B says, what is the area of this cross section? Well, the area is 1/2 times the base times the height. Which makes the area 45 millimeters squared. Next, I'd like for you to try some practice and problem-solving questions. You may now work on 6, 7, 8, 9, and 10 in your book. We'll come back and check answers in just a moment. Take a look at question 6. See me if you have any problems. and then move on to number 7. Now check your work and answer with number 7. Again, come see me if you have questions. Otherwise, move on to number 8. In question 8, the butter slice is a rectangle that is 3 inches across the top and 2.5 inches tall. Now move on to number 9. Number 9A, the dimensions of that cross section are 9 feet by 3 feet. However, if you cut that figure horizontally, that means like a hamburger or hot dog bun, you would end up with dimensions of 5 feet by 9 feet. Number 10, part A, you have a rectangle as your cross section that has dimensions of 6 feet by 11 feet. For part B, it asks us about the possible dimensions if we had cut the prism at another height. And the answer is no. If the slice or the cut is parallel to the top and bottom of the prism, then all cross sections will be the same for that rectangular prism. In other words, they'll all have the same dimensions. On the last part of your practice and problem solving, let's work on questions 13, 14, 15, and 16. In question 13, you're asked to use the area of the cross section and work backwards to find the length of the side of the base of that pyramid. Since the length of that side, base of the pyramid, is x, then that means that in the cross section that is also the length of the base of the cross section. The cross section also we see has a height of 13 yards, and then the problem tells us that the area of that is 52 square yards. So if you look here, I have substituted in to the area formula to find the area of that triangle. Since 52 square yards is the area of the cross-section triangle, and I know that that's equal to half times base, which is x, times height, which is 13, then I can use that information and solve. So using my properties that allow me to rearrange numbers in multiplication problems, I took 1/2 times 13 and got 6 5/10. Now my equation is a one-step equation that says 52 equals 6 5/10 times x. So to solve that, I need to divide both sides by 6 5/10. And you should have gotten x equals 8 yards. Now go on to number 14. Now take a look at number 14, part A. The cross section is a triangle that has dimensions 14 along the base and 18 as its height. So what is the area of this cross section? Well, remember, area is 1/2 times the base times the height. And that makes 126 inches squared for the area. Now move on to number 15. Miranda says that the triangle below represents the cross-section of the rectangular pyramid shown. What mistake might Miranda have made? Well, when you take a look at the cross-section that Miranda drew, you see that the cross-section actually intersects this side right here that's marked 13 centimeters. So her pyramid and the cross-section intersect along that edge. The edge of her pyramid, the bottom edge rather, is the same as the left side and right side of that pyramid, which would be 9 centimeters. So what mistake did Miranda likely make? She thought that 13 was the base of her triangle. When the base was really 9. last but not least, let's take a look at question 16. Part A says the horizontal cross-section has the same shape and dimensions as which sides of the right rectangular prism? Select all that apply. Since this is what we would call a hot dog or a hamburger cut, then what we know is that this cross-section has the same shape and the same dimensions as the top face and the bottom face. The left, front, back, and right faces are intersected by that cross-section. In other words, we cut through the left side and the right side, and we cut through both the front and the back of that prism, which means those cannot be the same shape and dimensions as our cross-section. In part B, it asks us for the area of this cross-section. Since it's a rectangle, the area is simply the length times the width. In this case, the length is 8 and the width is 6. So the area is 48 centimeters squared. Now you're ready to try some work on your own.